Alright, welcome back. Today we're going to talk about relative extrema. The first type of extrema is a relative maximum. A relative maximum is the highest point on the graph in its area. This should be on both sides of that point, and I like to think of these as the peaks of hills. Peaks. And so anywhere we see a hill, that top of that hill is a relative maximum. So there we go. Those 3 points that I marked in red are relative maximums. Those are the very tops of the hills. Another way to think about it is if we were to just draw a little window around that point, that is the highest point in that little window. So that's what a relative maximum will look like. Highest point in its area on both sides, which means places like the ends over here where the function's always increasing, like on these two sides, they are not relative maximums because each point has a point just to the right of it that is slightly higher than it. So those don't work. We want it to be the crest, to be the peak of a hill. So that's what a relative maximum looks like. Relative minimums, on the other hand, are going to look like little valleys, and those are the lowest point on the graph in its area on both sides. So we want to write valleys is the other way that I think about it. And so that's going to be these points. Those 3 points are the relative minimums. And the same thing goes for minimums. When I draw a little window around those points, it is the lowest point inside that little window. And again, if we look over here on the left side or over here on the right side, there's still points lower than it as we look to the left, so that none of those points count as relative minimums, since there's always a point immediately next to it that is slightly lower. Now that we've talked about relative maximums and minimums, we've got to talk about absolute maximums and minimums. So an absolute maximum is the highest point on the graph, period. That means no matter what, that is the highest point possible. And then the other type of absolute would be the absolute minimum. So I'm going to go ahead and draw us a picture of what an absolute maximum might look like. So the function's going to come up, it might wiggle around, but then it needs to go back down. It can't continue going up because we need that point. We need some point to be absolutely the highest point. Another way I like to figure this out is if you draw a horizontal line through that point, it should be the tallest point and not touch the function again, or none of the rest of the function should lie above that horizontal line somewhere else. So that point that I put in blue would be an example of the absolute maximum. Notice that the outsides, the arms of the function, are pointed downward so that they're not coming back up to interfere with possibly being the absolute maximum. The absolute minimum is going to look sort of the same, except the image is going to be a little flipped. So if I look like this, and then I want the graph to come in, and it might dance around, and at some point it's going to have the lowest possible point. And again, that lowest possible point is going to be the absolute minimum. It is the lowest point on the graph, period. No exceptions, no other rules. And if I look around, again, nothing matches that lowest y value to give us the absolute minimum. Now, looking at different types of graphs, some graphs might have an absolute maximum, some graphs might have an absolute minimum. It's possible for a graph to have neither an absolute minimum or maximum. For instance, the graph that I drew over here at the very beginning of the video, this graph doesn't have an absolute maximum or minimum, since the function continues downward as I go towards negative infinity with my x values, and it also goes upwards on that right side. As x gets really large, the y values will continue to get large. So there's no absolute minimum or maximum for that graph. It is possible to have both. Those graphs are going to be bounded a little differently. A quick example where you would consider the function having absolute minimums and maximum would be the graph of sine or the graph of cosine, which oscillates between 1 and -1. And so then 1 and -1 would be the absolute minimum or absolute maximum. I should also say that since we're basing these on y values, for instance, the absolute maximum gives me the highest y value possible, and the absolute minimum gives me the lowest y value possible, we also need to consider that sometimes we're going to talk about the x value that comes with those things, because we want to know what value we put into the function to get that maximum value or minimum value out. So all things to keep in mind. Just a nice recap of relative extrema. Once again, if you've got questions, leave them in the comments for me. See you next time.